Hello and welcome. In this video, we'll explore how to generate random numbers using C++ with modern facilities. Random number generation is a crucial aspect of many applications, and C++ offers powerful tools to accomplish this effectively. Let's dive in. Random numbers are essential for a wide array of applications. They are commonly used in games and simulations to create unpredictable events and scenarios. In statistical sampling, random numbers help ensure unbiased data selection. Cryptography relies heavily on random numbers for generating secure keys and encrypting data. Moreover, they play a vital role in testing and validation processes and are indispensable in randomized algorithms. Now let's look at how random number generation has evolved in C++. Traditionally, C-style functions like rand and srand were used. However, modern C++, particularly from C++11 onwards, introduces the random header, which provides more sophisticated engines and distributions. These modern facilities offer better statistical properties and provide more control over the generation process. Let's examine the traditional C-style approach using rand and srand. First, include the IOStream header for input, output operations, the xlib header for rand and srand functions, and the time header for the time function. Inside the main function, seed the random number generator by calling srand with time passing null pointer as its argument. This initializes the random number generator with the current time. Generate random numbers between 1 and 100 by using the rand function. The modulo operator, denoted by the percentage symbol, limits the range of the random number, and adding 1 shifts the range to 1 to 100. Finally, print the generated random numbers to the console. However, this approach has issues like poor statistical properties, limited range control, and global state, which makes it less desirable for modern applications. Modern C++ introduces the random header, offering significant improvements over the traditional C-style approach. This header includes various random engines, such as standard Mersenne Twister engine, which is a widely used high-quality engine. Default random engine is another commonly used engine, while random device provides a source of non-deterministic random numbers. Min standard rand is a minimal standard engine, and RandLux24 implements the RandLux algorithm. Additionally, the random header offers diverse distribution types. Uniform int distribution generates integers uniformly within a specified range. Uniform real distribution generates floating point numbers uniformly within a specified range. Normal distribution produces numbers following a normal distribution. Bernoulli distribution is used for generating Boolean values with a specified probability, and discrete distribution generates integers based on specified weights. Let's explore a basic example using the uniform integer distribution. Start by including the IOStream header for input, output, and the random header for random number generation facilities. Inside the main function, create a random number generator. Use random device to obtain a seed for the random number generator, and then create a Mersenne Twister engine, seeding it with the value obtained from random device. Define a distribution such as uniform int distribution, specifying the range of integers, for example, from 1 to 100. Generate random numbers by calling the distribution with the random number generator, storing the result in an integer variable. Finally, print the generated random number to the console. Now let's see how to generate floating point random numbers using uniform real distribution. Include IOStream, random, and IOmanip headers. The IOmanip header is for setting the precision of floating point numbers. Create a random device and use it to seed a Mersenne Twister engine. Next, create a uniform real distribution, specifying the range for the floating point numbers. For example, 0.0 to 1.0. Use standard cout with fixed, and set precision to format the output to a fixed point notation with 6 digits after the decimal point. Generate a random floating point value by calling the distribution with the generator and output it to the console. Let's summarize the best practices for random numbers in C++. It's highly recommended to use the random header instead of the old C-style rand function. Always seed your generators properly with random device to ensure better randomness. Choose the appropriate distributions based on your specific needs. Reusing generator objects improves efficiency by avoiding unnecessary overhead. On the other hand, it's best to avoid using rand for serious applications due to its limitations. Avoid creating a new generator for each random number, as this can be inefficient. Don't use time-based seeds for security purposes, as they can be predictable. Also, remember that not all engines have the same properties, so choose one that suits your requirements. Modern C++ provides powerful tools for generating high-quality random numbers, so take advantage of them. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.